Hi, everyone. Thanks for joining the session with us. And welcome to the day one of OpenSearch Con. So Tyler and I will be going to talk about a visual AI search flow builder in OpenSearch to build GenAI and vector search solution faster. So I'm Owais Kazi, a software engineer at AWS OpenSearch.
My name is Tyler Ohlsen. I'm also a software engineer at AWS OpenSearch.
So in the world of today, where people are using AI and are a lot of interested in the GenAI application, and they want to release those features quickly. They don't want to spend more time on how to set up things up and to build the whole application about. It's more of like you have something, you build it, and you release it. With lots of new LLM models coming up every day, lots of GenAI applications coming every day, the main factor here is like how the setting up complex things can be simplified. So this is where Flow Framework comes into a picture. I will try to explain this as an example. So let's say we have an example of an organization who has a couple of documentation, which they want to give it to their employees to have some kind of searches or some kind of like a chatbot through which they can search, basically a RAG-based solution. So what they'll do is like they can try to ingest that whole documentation or PDF directly into the OpenSearch cluster and then try to search on it. But this whole thing, it requires a setup and then making some kind of call, probably a conversions call or semantic call based on the use cases. The previous slide. So this is where Flow Framework Backend plugin comes to the picture because it will try to simplify the whole experience for you. What it will do is like it will provide you with a simple templates out there, a one-click setup so that the whole RAG-based solution can be done, and then employees can start using it directly. So let's talk about, so I'll talk about the Flow Framework Backend plugin and a couple of details about that with a demo. And then Tyler will explain you a visual treat with the AI search front-end plugin. So to begin with, I will start with a manual setup for hybrid search. There are a couple of different use cases of ML uses already present in OpenSearch, but I want to start with or begin with one of them. So I picked up hybrid search just to give an example or gist of how Flow Framework would help us here. So to do the current manual setup for hybrid search, it looks like you have to create a connector with a remote model. And that remote model can be a text embedding model because we have to generate embeddings with that model. Once we do that, you have to register an embedding model using the connector ID which was created before so that model is now part of your OpenSearch and it knows like this model will be helping you to generate the embeddings on the documents. After that, you will create an ingest pipeline which will help you to generate the vector embeddings on. So this ingest pipeline, the job would be like any documents which are actually ingested in the cluster will be generating vectors embeddings on. And you also need a KNN index because those vector embeddings generated needs to be stored on some index, and that's where KNN index comes into the picture. And then you need a search pipeline with a normalization processor because normalization processor would help us to create normalized score. Because in hybrid search, what happens is like you have different type of subqueries. You have lexical queries, semantic query, neural query, I would say KNN query, and all this lies on a different scale. And normalization processor would actually help you to normalize the score so that it comes on the same scale. And then you start ingesting and performing a hybrid search on the index. So yeah, that was a whole manual setup. Too much, right? So moving on, that's where Flow Framework Backend plugin comes to the picture. It actually tried to simplify and the whole cumbersome process of setting up and streamlining the setup for any type of use cases which OpenSearch offers, be it hybrid, multimodal, conversation, or a RAG-based solution, anything. It provides you the whole setup with just one-click APIs. We had a couple of templates automated templates which we provide for the common use cases, but that doesn't restrict user to create their own templates. They can actually create their own templates for the customizable use case for their own solutions. And then the next part is like, the main purpose is like it eliminates users to calling those multiple APIs which I just showed before, like the connectors and everything. You just call one API, it takes care of calling those multiple APIs for you on the transport layer client, and thus reducing the whole process of waiting for those APIs response as well. Now this looks fascinating, but how can we show that in a demo? So let me quickly go through a demo with that with the same hybrid search use case. So for the demo, I'll be using one of the Amazon reviews dataset, which has a couple of different sub-data set. Out of that, I'll use one of the gift card dataset. And I'll use hybrid search with a local model. So this is the one-click API I was talking about. This is the Flow Framework API. I have a use case, hybrid search with local model, and a hybrid search with local model as a use case. And these are the couple of body requests I'm passing out here, which can be like the index name, field on which I want to create embeddings on from your document, and the output dimension of the vectors. So I'm using 384 vector dimension. To actually explain this more in further, so we have lots of automated templates out here. And since we are talking about the hybrid search with local model default, these are the defaults default value which we have, like the ingest pipeline name, model ID, pipeline ID, then the search pipeline ID, all this kind of thing. You can override any fields you want. So out of that, I am selecting other ones. So I have the index name as gift card, and let me try to provision this. So it has returned me a workflow ID, but to give you understanding about like what is happening at the backend is like it is actually creating the ingest pipeline for you with the text embedding model. It has registered a text embedding model. It has created a search pipeline with the normalization processor. It has created a KNN index, and basically the whole setup for hybrid search was done. Now let me see the status of this workflow. Yeah, so it says like the setup has been completed, and all of the resources which we just talked about are here, like the search pipeline, local model, deployed ingest pipeline, everything. So I'm going to use this index to ingest some sample data quickly. So this is my sample corpus. Yeah, so I have the documents ready now for my index to query on, and now I will perform a hybrid search call. So this is the same pipeline which we have created through the provisioning step, and this is a hybrid query. So I have a match query, a simple match query, and I have a neural query. I just have to use a model ID which we created through the same workflow. So I'm going to use the same model ID which my workflow has returned to me. And I'm going to make a hybrid search call. So yeah, as you can see, my hybrid search has returned me the responses based on my query, like pretty box, gift card, all this kind of thing. And the scores are normalized over here. And the whole setup of hybrid search was done pretty quickly. Like we have reduced the whole cumbersome steps within minutes, within small minutes, less time, and performed the hybrid search. So that's not where it ends. Since we did the whole provisioning with one click, let's try to do the deprovisioning with one click, like reducing or basically deleting the whole setup which we did, like deleting the ingest pipeline, deleting the search pipeline, or deleting the KNN index as well. So for that, same thing. I'll just use the workflow ID, and I'll try to deprovision my whole workflow. So it has started deleting all of the resources which were just created again right now. To prove that, we can actually quickly look into the model ID, whether it exists anymore or not. So when I try to delete this model, it says failed to find model because all of those resources had been deleted. So one of the example was this model ID. But yeah, the whole setup was done quickly with the Flow Framework plugin. Now moving on to the presentation. So now let's talk about how does it work in the backend. So what happens in the backend is like we have a backend plugin. We have the backend plugin here. A user sends us a template, and that template has different workflow nodes. So the job of every workflow node is different. Like one of the workflow node would do creating an ingest pipeline. Another workflow node would do creating search pipeline. Another workflow node probably would do creating a KNN index. So those workflows will be passed here, and that workflow nodes are actually DAG in nature, like directed acyclic graph in nature. So one of the API call would happen after another one based on their dependencies. And then once those API calls happen, a user will be returned back with a workflow ID. Once the user gets a workflow ID, user can actually use that workflow ID to check the status of the workflow, whether it has completed, it has failed, or it has not started yet. And once we get the workflow ID, and the status has completed, that means the whole provisioning is done for you and the resources are created. So this was a quick overview of a workflow sequence of how things are happening on the backend. So these are the couple of additional default and sample use cases we have, not just hybrid search, but we have a bunch of them. And that doesn't restrict you to use just those default templates. You can actually create more configured workflow templates like brag with conversion search or multimodal search or something like that. All you need is a sample workflow templates. So to show that quickly, I will show you one of the sample templates. How does that look like? So the sample templates look like this. If you want to create one, it's more of like one of the node is registering a local model. You have the user inputs out there for the local model. Then you need an ingest pipeline for the hybrid search, and it basically takes up the model ID, which was registered before, as the previous node input. Then you have the create index, and then you have a search pipeline. So this is how user can just configure or play with it and create more and more configuration. So yeah, that's it from the backend side. I will now hand over to Tyler to talk more about front end.
You can sit there. Cool. I'll swap laptops here. Cool. Yeah, so thanks, Owais. That's kind of the high-level kind of fundamental pieces that kind of make up how we can build on top of that on a UI. So I'll be discussing AI search flows, which is the visual flow builder that's kind of built on top of this flow framework plugin. So really kind of the main focus of this plugin is to be this developer tool to kind of help stitch together your actual complex ingest and search flows using available ML resources. So like Owais had gone over a hybrid search example, I'll kind of show that same thing and how that can be achieved on the UI using that plugin for handling all the resource management and everything behind the scenes, just so you can focus on kind of building your actual flow. It's heavily focused around ML inference processors, which I'll discuss more, but really what these processors allow is bringing any model you have, regardless of what its complexities are with its model inputs and outputs, and being able to stitch that at different points in your ingest and search flows to build the workflows that fit for your particular use case. And similarly on the UI, we have several different use cases, initially focused on different vector search use cases, so semantic, hybrid, multimodal, neural sparse, and some reg variations. And then kind of the final step in this process of using the UI as a developer tool is being able to export these flow framework templates, as Owais had gone over, which will then kind of encapsulate all the configurations that make up those ingest and search flows. So you can kind of use it to test maybe on a smaller data set and then go ahead and deploy that to different environments with larger data sets once you're satisfied with how your flows are being built. So with that, I'll first go ahead and do a demo on hybrid search using that same data set. So I'll kind of show what makes up the different components of the UI. I'll go over the hybrid search preset and then how we can kind of expand upon that to have a reg use case using a Claude large language model to summarize results on top of that use case. So. With that, I have this deployed hybrid search use case right here. So this is the AI Search Flows plugin. Each workflow encapsulates one of those templates. So you can create different use cases, iterate upon them, and go from there. So I have this hybrid search one here. So the UI is made up of three main components. On the left-hand side is kind of a side navigation. This will make up your high-level ingest and search flows. This is where you can add different components. And then clicking within any over here will then fill out the central form, which is the actual component where you would spend most of your time actually configuring things, stitching together those ML inference processors like I mentioned. And then on the right-hand side is where you would actually go ahead and like test your flow, so like execute searches, view different ad hoc responses, errors, view the provision resources for this particular workflow, et cetera. So with that, what I can quickly do, these panels are all resizable as well to kind of help you focus on what you really are interested in doing. So I can just, I have a very small data set here ingested for this use case for sports products. So I could do just a small search, maybe on football. We can view the different hits. We can view the raw search response. We can expand upon each of these hits and see, okay, we get NFL swimwear, so we're getting some sort of semantic related response from football. This obviously is not like a lexical search response. So I can talk a bit more on kind of what this hybrid search preset offers here in terms of these processors and what's going on behind the scenes. So starting from the ingest side, you would first provide some sample data. You would then just supply a model, and then all these processors will be filled out for you. So in this case, we're generating a text embedding on this title field for each of the documents that are being ingested, and then finally ingesting them into this pre-configured KNN index. Moving on to the search side, we have a query. We then have an ML inference processor on the search request side to actually parse out a piece of that request to generate embeddings on the field that we're interested in, and then actually generating a final hybrid search query using KNN and lexical search. And then it will actually run the search, and then we finally have that normalization processor, which will then normalize the weights against those two queries that was ran. So essentially, it's like what Owais showed, executing those backend APIs, but on the UI, and more freedom to then kind of iteratively change your configuration, swap out different models to test things until you get the results that you're happy with. So to kind of build on top of this, what I can then do is add an ML inference processor on the search results. In this case, I have a deployed Claude model. And so here is where you would define your data transformations, essentially. So depending on what your input data is to the model, how you want to format that data to pass it to your model, depending on whatever that model interface looks like. In this case, this model is expecting a single field called prompt. So I'll just kind of quickly gloss over this. Again, we can go over this in more detail if we want, but we can basically just select a prompt template. I can even run that sample query to kind of see what that input data is going to be at this point in the flow. And if I want to basically parse out that title field, maybe I want to pass all of the product titles in one big chunk to that LLM and say, hey, summarize these results for me. So I can configure it like that. I can then confirm and then just go ahead and update that search flow. And now we have that ML processor added to the end of our flow. So then I can run kind of that same query. And now we'll still get those hits, but then we also will now get this response from Claude in this case, just as this text is a list of various sports and outdoor products, including et cetera. So that would be kind of your summarized response if you wanted to kind of expand your application that way. So that's kind of just an introduction into how this plugin can be used to kind of iteratively, build your flows out as you're happy with one step, move on to the next step, and go from there. So. Okay, so moving on from that, I'll now kind of discuss something that's a work in progress here, which is Agentic search. I'll do this on the same data set. And for this particular use case, I'll be showing how we can just pass natural language to an agent, in this case with GPT-5, which will then take that natural language and actually understand the query and what the user is asking, the intent of it. It'll analyze the index that you're searching over, and then finally generate an optimized query for that. So this is for users who maybe aren't very familiar with the complexities around query DSL, and they want to just leverage an agent for actually generating that query for them. So this is kind of a newer enhancement, which kind of fits into that search flow. And so what we want to do on the UI is support that and have users be able to test these things out quickly with different agents. So I'll now go ahead and show that use case as well. So let me. Cool. So from the home page, I can go to create workflow. I can then select agentic search. And then from here, I'll first just kind of show the minimal required inputs, and then we can go into a bit more depth onto what we can configure and kind of what we see for the future for this. So this is a bit different layout. It's less focused on the ingest side. It's less focused on the individual pipelines and more on just configuring different agents and being able to test out how that agent performs. So I have a sports and outdoors. This is a larger data set, around 1 million products related to sports and outdoors. I have a pre-deployed agent here, in this case using GPT-5. And then I can just begin asking questions over this sports and outdoors index. So maybe I'm someone that's trying to get into golf. So we can just take that as it's kind of a product search use case. So I can say, maybe if I'm first not familiar with the brands, so I'm going to search most popular golf brands for golf clubs. So we can run that search. Okay, so we get some results here. I can then look at that generated query. So this is that actual query that was then executed against that index. In this case, it did a match query on the categories field for golf clubs, and then it did an aggregation. It found this field in the index called details.brand. As well as you can view the raw response here as well. So maybe I can run it again and kind of see, how it's if it's producing different queries, you can kind of test out different things you can do. For example, on the search query, like you can add different query fields. So in this case, this will basically nudge the LLM, nudge the agent that you're using to maybe focus on these particular fields. So if you are familiar with your index more, you can kind of pass it, a bit more hints into, hey, I'm looking for golf brands. I want to focus on, categories or things like that. Okay, so with this hit, we have our list of hits here. I see Callaway is like the top one. So again, this generated kind of a similar query. So now maybe I'm satisfied. Okay, I want to drill down a bit more into Callaway clubs. So maybe now I want to search top 10 golf clubs, and maybe I have some budget from Callaway. So again, just using natural language, and I'll go ahead and execute that search. Cool. So now we get a list of hits here, some bags, some hybrid clubs. So starting to get more into what we're interested in, and then we can also look at the price, verify that the price makes sense. We can again look at that generated query. We see in this case it did a Bool query, it did a filter from 100 to 200 on this price field that it found, and then it also did that match query. Okay, and then maybe I want to sort by average rating, so you can take it a step further and say also do sorted by average rating. Cool. So again, it looks like we're in our price range. This top one has an average rating of 5, 4.9, 4.9. So it looks like that's kind of the hits that we're interested in. But maybe in this case, we're getting closer, but maybe we have some of these noisy fields that we're not interested in. For this particular use case, like images, we don't really care about returning those things. So now I can say, just return the title, price, and that average rating. Those are just kind of the key things I'm interested in. Cool, so now we just get those 3 fields returned. And again, we can look at that generated query and see we have that includes title, price, and average rating. So again, it's kind of just relying on that agent for actually generating that query for us. And you may learn things if you're kind of searching on a new index. You can use it to kind of figure out what that index schema looks like and what are some of the types of queries that you can run against it. I'll talk a bit more here on some of the configuration and how this kind of ties in to the Flow framework. So again, we can leverage Flow framework here for kind of handling all these resource provisioning. In this case, we can use this workflow for storing that search query, the index, any agent configurations. So it's kind of the same idea here. And we can use this UI for testing different agent configurations. Again, this is a pretty new emerging feature, so there's a lot of enhancements that are being made as far as different tools that we can add for these agents for expanding for different use cases, different RAG use cases, for example. Currently, we just have this one configured on the query planning tool just for that natural language query use case. As well as you can drill down into what that actual agentic search query looks like. In this case, just this query text. And then if we want to add, like I mentioned, more of those query fields, you can play around with those different features to try out different agentic search queries. Cool. Jump back to the slides. Cool. You want to take this page?
Yeah, so thanks, Tyler, for explaining the agentic search, which is a new coming feature soon. We have released the experimental feature in 3.2, and it will be GA soon in 3.3. So what's coming in for Flow Framework Backend plugin is like we have to onboard this agentic search variations like natural language query, RAG, and a couple of other things like different tools which agentic search offers, like web search tools and all those things. We have to onboard more agent types. Right now on Flow Framework Backend plugin, we have Flow agent, but we also want to support like conversion and plan and execute agent. And this is new thing, model context protocol for OpenSearch, which has been released in 3.0, and we are soon basically trying to onboard it to Flow Framework Backend plugin as a one-click template as well.
Cool, yeah, and then similarly for the front-end plugin, very similar goals. And as these emerging features come out, we want to see how we can leverage these and have these new use cases and presets built out on the UI to really help users have an easy entrance into kind of being able to take advantage and leverage these capabilities as they become available. So obviously one of those key pieces would be onboarding these agentic search variations as they become available, having further remote connector and model provisioning from the UI as well to really kind of help this UI be a one-stop shop for kind of the full end-to-end experience, and then just general simplification, minimizing friction and having the least amount of inputs required for users to at least get started and drill down into building things more customized and playing around with what those features can offer as they get familiar. And yeah, obviously testing and feedback is much appreciated. We have the GitHub issue there, which is just our meta issue on the backend plugin for different use cases and different preset templates that you would like to see and be interested in. Obviously, feel free to add your thoughts there, and the slides will be available. And then we have just one more here as well on this. It just links to our GitHub repos and the documentation for the respective plugins. We can leave that up for a moment. Cool. And with that, yeah, thank you all for attending, and we will take questions now. Yeah, if anybody's interested in more things on...
Yeah, any questions or anything? So basically, with Flow Framework, we wanted to build a marketplace for all of the AI use cases of OpenSearch, a one-stop solution. You just use the same one plugin, and it provides you with a bunch of use cases. Yeah, go ahead.
Thanks for your presentation.
Mm-hmm.
So are these available, are these plugins bundled in with the normal distribution?
They are.
Both of them are?
Yes.
Okay. Is it only with 3.x or with it?
No, with 2.x. So I think...
with 2.12, we released Flow Framework Backend plugin in 2.12 and front-end in...
Front-end was 2.19.
Yeah.
Mm-hmm. Yeah.
Oh, that's why I see it with front-end. Okay.
Yes, yeah, it's a newer plugin, yeah.
Yeah, thank you.
Mm-hmm. Yeah, and like I mentioned, kind of the initial focus was on those vector search use cases, right? And then as new things become available, we want to try to build an easy way to onboard new use cases and have these easy experiences to be able to test them out on a UI as well. So,
yeah, go ahead.
So for the agentic search, if I heard you correctly, it started for 3.3?
Yeah, GA is targeted for 3.3, but we have released the experimental feature of agentic search in 3.2, just to play with. It provides right now a simple way of converting your natural language query to DSL query, but in 3.3 we plan to include more tools as well, like if you are not able to find, if the query is not able to find any data on the OpenSearch cluster, it will use the web search tool to search on web, return you the answers, summarize your answers, and a couple of things like that.
Okay, is there any public dates for when AWS itself will support 3.x?
In 3.3, probably around October mid.
Okay, how about 3.0? I think right now, if I understand correctly, it's 219, what AWS supports, right? So do we have dates on 3.0?
3.1.
3.1, so you're saying like when did the 3.1 release happen? Because it already happened.
It happened already on
Yeah,
AWS?
yeah.
Okay, last time I checked, it was 219.
Oh, on AWS, okay. On AWS, it's gonna take some time. I think it's gonna be October, something in some place in October.
Yeah, it's in progress, but it won't have, with Agentic Search being on 3.2 and GA and 3.3, it won't be part of that until the 3.3.
Yeah, but the other use cases will be available except agentic search.
Right.
Thank you.
Yep.
Yeah, go ahead.
So let's say I have a bunch of custom indexes in OpenSearch. How will this natural language search know to translate my query into which index to hit in my backend?
Yeah. So right now in the experimental release, we are actually focusing on one index when we make the search call because it's a new query clause on that index. But in the 3.3 release, the way it's gonna be like, we would have an index mapping tool and an index insight tool. So based on that, no matter which index you select, you just make a search call. That index mapping and index insight tool will actually give the insight of the index to the LLM. It also provides the mapping to the LLM so that it knows which index would be the right one to make the search call on. It will select that index and make the search query.
Yeah, then I guess you could touch on search templates as well.
Yeah, and we will also have search templates. So if you have some, I would say, advanced search queries and everything, which are running right now on the search template. So if those queries are not presented by LLM in a good form, then we can actually utilize the search templates, user-defined search templates, and make query based on that.
Yeah. If you have, some predefined, very complex queries that work well, you can pass that as context and say, hey, maybe just tune a few things here, but leverage these templates that you already know are working and performant for your search. So.
Yeah, go ahead. I'll take you next.
Thank you for your wonderful section. And would it be available to ask multiple indices when using agentic search?
Yeah.
Your question would be analyzed by mapping of index automatically, right?
Yes. So index mapping tool will be helping us here, which will basically give you it will actually pick up the right index mapping for the index and send it as a context to the LLM. Also, there's an index insight tool, which is right now in progress and development, which will help you to get the insight of that index. What field would describe what exactly? So that LLM knows like, okay, this is a category field, so it should have category elements, and I have to make whatever the query I get, I have to make category related questions on this field exactly.
So are you saying that if I ask same questions to multiple indices, then the answer would be just same, or?
No, so whenever you ask on multiple indices, the index mapping tool would actually select the right index for you for that specific query. Yeah. Yeah.
So when you use agentic search, is there a way to get insights into the model cost?
In the model?
Cost.
Model cost. So right now in 3.3 we are actually bringing on in OpenSearch open source, we are bringing in bring your own model. So the cost would be incurred by the user itself. But in the managed service side, probably in 3.5 or later, we plan to have a hosted model. And that will be like probably a Claude model or something like that, which would be, the cost will be given to the users based on that, like how many number of tokens, based on number of input tokens and output tokens, what will the cost be.
So when the search query is generated, is there a way to set rules around load by these fields?
Yes, there are rules. So if you want to give more rules right now, you can provide the query fields on which you want to make queries on, and there will be a filter as well on which you don't want to, because there might be some sensitive data on those fields. Yeah. Yeah, I'll take your next. You go ahead.
So you mentioned that this feature is already bundled in with 3.2 and another one with 3.3, or are they going to be separate plugins that we have to import and
So the Flow Framework plugin, the Backend plugin, is bundled with OpenSearch 2.12 already, and front end is in 2.19.
Yeah, front end's in 2.19. The agentic search piece is targeted for 3.3.
Yeah, that's a use
that's-
case
yeah.
of Flow Framework plugin. So, and which we are building separately. That's completely separate, which we are building, and that will be GA'd in 3.3. And later on, we'll have more support of agentic search in Flow Framework plugin.
And is it going to be a plugin or is there any plan to bundle it into Core as well?
So it's gonna be a new query clause. It will be part of Core itself. Similar to hybrid query, you will have an agentic query. Yeah.
Right, yeah. The feature itself is really just that new query clause, the agentic query clause, yeah.
Yeah. It has been released in 3.2. Like if you wanna play and try with the initial, you can do it. Yeah. Yeah. Yes.
The index mapping tool is, so the purpose of building the query context, is it sampling the data within the index, or is it just using the column names, the field names to generate that?
Sampling, as in, are you talking about the sensitive information or just the fields which are present in the index mapping?
I mean, the fields in the index map, so how is it building, how is it generating the contextual understanding? So in order to generate a natural language query with an understanding of the data that resides within the index, is it sampling that in order to build
Yeah. So index mapping.
field names?
Okay. So index mapping tool is actually just fetching the index mapping for that specific index, but the index insight tool is basically helps the LLM to understand what the field would actually means. Let's say I have some field, what does it mean in terms of context, and both of these tool will help LLM understand this is the index, this is the mapping for it, and this is the inside of that index. Based on that, it will get some idea, okay, these are the fields I can query on for that specific natural language query.
But it's just based on field names that are
Yes.
in the template, not the actual data within the index itself.
Yeah, it's based on the field name because there's a limit context we can share with the LLM, right? We can share few sample documents like 4 or 5. That can be one thing. We can share the index mapping and we can share the natural language query. These are the limited contexts we can share on a hot path search request with the LLM.
Cool. Yeah, we are at time here, so I think we'll have to
Yeah.
wrap up there. Yeah, any other questions, feel free to come up with us. But thank you guys.